This is the lesson for Chapter 5, Section 4, called Point Slope Forms. So let's take a look at what point slope is. So way back in Chapter 5, Section 1, we talked about the slope of a line. We said the slope of a line was the change of y over the change of x. And we wrote that change of y as y minus y1 over x minus x1. So change just means you subtract the two numbers. And that's what I end up doing here. So if the slope ends up equaling this change of y, and let me rewrite that, y minus y1 over x minus x1, what I could end up doing is solving for y. And the way I'm going to do that to start with is I'm going to go ahead and multiply this equation by x minus x1. So x minus x1. I'm going to put that in parentheses to show that's a difference that I want to multiply by. And what that'll do is it'll cancel out the denominator. But what I do to one side, I have to do the same thing to the other side. So once I do that, I've got a new equation. And the new equation looks like this. Y minus y1 equals m times x minus x1. And what that does for us is it gives us a way of writing an equation in slope-intercept form when we're given a point and a slope. So we still have the y value, which is our output. We still have a x value, which is our input, and we don't put anything in for those two numbers, but we do put numbers in for y1. So we're given a point, and so this given point is going to end up being our x1 comma y1, and we're going to substitute that point into this equation. So we're going to take our x1, we're going to put it in for x1. We're going to take our y1 here, and we're going to put it in for y1, and we're also given a slope. And that slope is going to end up being our m value. And we're going to use that and put that in for m. So this is called point slope. And so point slope allows us, again, to substitute a point and a slope so that we can write an equation. So we're going to practice doing that. So it says a line passes through this point and has a slope of -5. What is the equation of the line? So we're going to start with point slope. And so point slope, just that same formula that we used before. And so it goes y minus y1 equals m times x minus x1. So I substitute. You always keep the y value just as a y value. That's your output, but then you place the y value of the point into y1. So y1 is 6, x1 is -3. So I will write y minus 6 equals the slope of the line is m, which is -5, multiplied by x minus -3. So whenever you see that minus negative, that will change to a plus positive, and then you distribute. So when I do that, I've got y minus 6 equals -5x minus 15. Minus 15 because I did -5 times +3. So this is the answer in what we call point slope. And so if they just want point slope, this is what they're asking for. If we wanted to solve a little further and put it in slope-intercept form, then I would end up having to move that -6 to the other side of the equal sign. So I could do that by just adding 6 to that -15 and getting y equals -5x minus 9. And see, then we can graph that equation. And so this is slope-intercept form. So there's two different forms. We've got the slope-intercept form and the point slope form that we are going to be dealing with. Here it says a line passes through this point and has a slope of 2/3. So again, the x value, or x1, is the 8. The -4 represents our y1 value. So we're just using the point slope formula. Y minus y1 equals m times x minus x1. So I go ahead and substitute. Y minus -4 equals the slope of 2/3 times by x minus 8. So again, whenever I see that minus negative, right away I change that to plus positive. And then I'll distribute that 2/3 over both sides, and I've got this. Y plus 4 equals 2/3 x minus 16/3. So all I did is just multiply straight across 8 over 1 times 2/3. 2 times 8 made 16. 3 times 1 made 3. So my last step is to subtract the 4 from all sides. Again, this is point slope, so if they just wanted it in point slope form, this is all we would do. We just leave it exactly like this. That is a 3 down below, so this is point slope. Now if they did want us to write it in slope intercept, then I would have that extra step of subtracting 4. Now as I treat 4, since I've got to deal with the 16/3, I'm going to multiply it by 3 over 3, and I end up having a 12 over 3. So I'm taking that away because I subtracted it from both sides, so whenever you see the same sign, you end up adding. So my number here would be y equals 2/3 x minus 28/3. I just leave the answer just like that in that improper fraction form. If I wanted to graph it, then I'd have to figure out what this number was in a mixed number form or a decimal form to help me graph that point. And so again, this is called slope intercept. Slope intercept form. So let's take a look at some other types that we might end up seeing. Here it gives us the equation in point slope, and they're asking us to graph the equation. So the first step we're going to have to do is put it in slope intercept form. So I'm going to go ahead and distribute the 2/3 over that subtraction. So I've got 2/3 x minus 4/3. And then I have to add the 1 to all sides. So when I add 1, I'm going to change 1 to 3/3. And I'm adding 3/3 to that negative 4/3. So they're opposite signs, so I subtract. So that leaves me with negative 1/3. And I still have that 2/3 x, and that all equals y. So now I know what my slope is. My slope is 2/3. My y-intercept is negative 1/3. So what I do is I go 1/3 of a space down. And I put the dot right there, so it's a little below the origin, but not quite to the 1/2 mark. And then I follow the slope. The slope is 2/3. So 2/3 would bring me up here would be 1/3. 2/3 would be right there. And then I end up going, let's see, 1/3 would be right here, so 2/3 would be right here. Then I go over, let's see, 2/3, so I go over 3 spaces. So I can either go up 2/3 and over 1, or I could just go up 2 spaces, and that's what I'm going to end up doing here. So I'm going to go up 1, 2 spaces, and then over 1, 2, 3, and then place that point right there. So again, that's 1, 2, and then over 1, 2, 3. I could do that again, up 1, 2, over 1, 2, and then this point is going to end up being off the graph. I could also go the other direction. I could go down, down 2, so 1, 2, over 1, 2, 3. That gets me on that graph too. So this would be what the line would look like. So let's take a look at the next one. Again, it's in point slope form, so I'm going to distribute. So I've got y plus 7 equals negative 4/5 x, and then plus this time, because the 2 negative signs make it positive, and that makes 16/5. So when I subtract the 7 from all sides, I'm going to change that 7, I write that 7 as multiplied by 5/5, and so that makes 35/5. So I'm taking that 35/5 away from the positive 16/5, so I end up having to subtract those 2 numbers. So when I do that, again, you got to make sure you get the bigger number on top when you do that subtraction, and then borrow, and that's where I end up with 19. So 19/5, and it's negative, is going to end up being the y-intercept. Negative 4/5 is the slope, and this all equals y. So here's where we, since we're trying to graph it, we need to figure out where is negative 19/5. Well, negative 4/5, that's just my slope. I leave that as a fraction because that's going to tell me what to do in the y direction and the x direction. But this 5 goes into 19. We have almost 4 times, so not quite 4 times, but it's going to be negative 3 and 4/5. So that tells me where to start. So I'm going to start 4 spaces, or almost 4 spaces down. 1, 2, 3, 4, so just a little bit less than that. And then I'm going to follow the slope. So it says down 4, but I can't go down 4, so I'm going to do the opposite. So again, the slope of that line is negative 4 to 5. But that's the same thing as saying positive 4 to negative 5, and that's the one I'm going to use. So that tells me to go up and then left. So that way I can fit it on my graph. So up 4, so 1, 2, 3, 4, and then over 5 to the left. 1, 2, 3, 4, 5. And that's the only point I'll be able to fit on my graph, so I'll draw the line between those two. And that's what the graph will end up looking like. So a negative slope heading downhill from left to right. So those are some problems that you'll see on the homework tonight. Good luck.